next is C plus iota S method. C stands for cos series and S stands for sine series. Question is sum the following series 1 plus cos alpha over cos alpha plus cos 2 alpha over 2 factorial cos square alpha plus cos 3 alpha over 3 factorial cos cube alpha plus so on till infinity. First of all, you have to see the series in multiple angles and not power of angles. So we can see this series is having terms cos alpha, cos 2 alpha, cos 3 alpha. So multiple angle series in cos. So it is cosine series and we will denote cosine series with C. Let C equals to 1 plus cos alpha by cos alpha plus cos 2 alpha by 2 factorial cos square alpha plus cos 3 alpha by 3 factorial cos cube alpha plus so on till infinity. Now corresponding to cosine series we want to find sine series and sine series will be denoted by S. See if in cosine series we have constant 1, then in sine series it will become 0 because we want to find C plus iota S. So 1 in complex number form can become 1 plus iota into 0. So if we are given constant 1 in cosine series, we will take 0 in sine series and in other terms of cosine series in which we have multiple angles of cosine, only that terms will be changed to sine terms, not the power terms. So cos alpha will be changed to sine alpha and in denominator cos alpha will remain unchanged. Again cos 2 alpha will be changed to sine 2 alpha and in denominator square root 2 cos square alpha remain unchanged. Again in third term cos 3 alpha will be changed to sin 3 alpha and in denominator factorial 3 cos cube alpha remain unchanged. Next step is to find C plus iota S, means C series as it is and we add S series by multiplying it with iota. So we will add like terms and we will get, see first term 1 plus iota 0 means 1. Second term cos alpha by cos alpha plus iota sin alpha by cos alpha. So we will get 1 by cos alpha common and we will have cos alpha plus iota sin alpha. Again see next third term 1 over 2 factorial cos square alpha can be taken common and we will get in numerator cos 2 alpha plus iota sin 2 alpha. Again in fourth term we can take 1 over factorial 3 cos cube alpha as common and cos 3 alpha plus iota sin 3 alpha in numerator and so on. See next step 1 plus cos alpha. Now cos alpha plus iota sin alpha can be written as e raised to power iota alpha. Cos 2 alpha plus iota sin 2 alpha can be written as e raised to power 2 iota alpha. Cos 3 alpha plus iota sin 3 alpha can be written as e raised to power iota 3 or e raised to power 3 iota alpha and so on. Now 1 over cos alpha can be written as secant alpha, 1 over cos square as secant square alpha, 1 over cos cube as secant cube alpha and so on till infinity. Now now we can taking powers common, we will get its power as 1, its whole power as 2, its whole power as 3. If we take this term as z, we will get expansion of 1 plus z square by 2 factorial plus z cube by 3 factorial plus so on till infinity, where z is secant alpha e raised to power iota alpha. Now this is expansion of e raised to power z. Now substituting the value of z here, we will get this. Now substituting value of e raised to power iota alpha as cos alpha plus iota sin alpha. Now secant alpha is cos alpha and this cos alpha will be cancelled out and become 1. This secant alpha is 1 over cos alpha, sin over cos is tan alpha. Now again see, breaking the basis, splitting the basis, we will get e raised to power 1 into e raised to power iota tan alpha. This is our C plus iota S expansion. E raised to power iota theta is e raised to power this e common and e raised to power iota theta is cos theta plus iota sin theta. Now we want cosine series. As in statement we have cosine series equating real parts which is independent of iota. Here it is c and here it is e cos tan alpha.